Alright, Sabri, I'm going to quickly try to get through these problems and to help you out. Hopefully you can see this video. If not, feel free to pause it or zoom it in. Hopefully you'll be able to see it, and it'll help you a little bit before we meet again to start studying. So for number 1, I'm taking the point 4 for x and 2 for y and plugging it into the system 4x plus y equals 14. The other one is 2x plus y equals 0. So if I plug in that 4 for x into that top equation, it gives me 4 times 4 plus 2. And I can see right there 16 plus 2, that does not equal 14. So that point definitely did not work in that first one. When I take that second one and plug in 4 and 2, I could see that one also does not work. That gives me 10 equal to 0. That is not true, so that's a big no on that one. Number 2 has you solve by substitution. So x minus 2y equals 4. And the other problem is 2x minus 3y equals 3. When I do substitution, I like to split them up a little bit. My first step is to solve this one for x. So that means get that x all by itself. Second step means take this piece right here and substitute it in the other problem's x. So that's where I'm going to substitute. So right here I got 2, and where that x used to be, I'm going to put the 2y plus 4. I still have that minus 3y equal 3 right there. Got to distribute this, which gives me 4y plus 8 minus 3y equals 3. Going to combine my like terms right there. 4y minus 3y gives me 1y plus 8 equals 3. Take away 8 both sides, and that gives me y equals negative 5. Half of my answer written as a coordinate, negative 5, goes right there where x is. I'm sorry, where y is. Now I'm going to take that and I'm going to plug it back in here to find out what x is. So x equals 2 times negative 5 plus 4 equals negative 10 plus 4. So x equals negative 6. And that should work. If I plug them in there just to check, negative 6 minus 2 times negative 5, that's negative 6 plus 10, and you could see that one works. If I plug it into the second one, 2 times negative 6 minus 3 times negative 5, that gives me negative 12 plus 15. So you can see that one also worked. So that point is a solution for sure. Number 2. Number 3 has you solve it by addition method. So I'm going to stack one on top of the other. And I'm going to add straight down. The way it's set up, it's not going to work. Nothing's going to cancel. So I'm going to take that top row and multiply everything by negative 1. That will make this 2x positive, which will cancel away that negative 2x on the bottom. So when I do that, my top row becomes positive 2x minus 4y equals negative 10. And my bottom row stays the same. And now when I combine them, these cancel. Negative 4y plus y gives me negative 1y. Negative 10 plus 4 gives me negative 6. Still not solved for y, so if I divide by negative 1, I get y equals 6. And again, that is half of my answer to solving a system is 6. I'm going to take that 6 and plug it into either of these to solve for x. I'm going to take this bottom one here, and where there's a y, I'm going to plug in 6 into that. That gives me negative 2x plus 18 equals 4. Take away 18 on both sides. Gives me negative 2x equals negative 14. Divide by negative 2. Gives me x equals 7. So that point is 7, 6. Pretty sure that works. I'm not going to do the check for that one. Number 3. 3 says solve the system by graphing. Confirm your answer by checking. So for number 3, here's number 3. I have x minus y equals 5. And the other one is x plus 3y equals 9. So to solve those for graphing, I need to solve both of those for y. So this first one, to solve that for y, I'm going to take away x on both sides. Make sure to bring down negative y. Write this in slope-intercept form. This is negative 1, so I'm going to divide everything by negative 1. And that gives me y equals 1x minus 5, ready to graph. This one up here, I'm going to subtract x on both sides. And that gives me 3y equals negative x plus 9. Divide everything by 3. And that gives me y equals negative 1/3 x plus 3. So when I graph that, your y-intercept, your x-intercept, your x-axis, y-axis, this one has a y-intercept of negative 5. So I'll go down to negative 5. That's where my first point goes. The number in front of x, written as a fraction, is 1 over 1, which means from negative 5, every time I go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. I could stair step the opposite direction too. So that is the equation y equals 1x minus 5. When I graph the other one, this one has a y-intercept of 3 and has me, every time I go down 1, I go over 3 for my slope. So down 1, over 3, down 1, over 3, down 1, over 3. And I could see they meet right at this point, right here. That is the point 1, 2, 3, 4, 5, 6, 6, 1. He wants you to check that one. So I'm going to take that 6, 1, and I'm going to plug it into both of my original equations up here. So that first one, x minus y, if I put in 6 for x minus 1 for y, you can see I get 5 equals 5. That second one, when I plug in 6 for x plus 3 times 1 for y, I get 6 plus 3, and that equals 9. So I can see that point did satisfy both of those equations. And I believe that was 1, 2, 3. That was number 4. I'm sorry about that. That was problem number 4. Sorry about mislabeling that. Okay, number 5 says choose the best answer below. See, where are the answers? Alright, so I'm just going to solve this one. 6x minus 7y equals negative 9. And the other one is negative 6x plus 7y equals 1. I'm going to do this by linear combination method. So I add straight down. Cancels, 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 cancels. I get 0 equals negative 8. When you get that situation where you get two unequal numbers, this is a no solution. This one would be one where two lines would never ever cross. Parallel lines. One solution is one like this where the two lines intersect at one point. But when you have everything cancel away and you get that, that's a no solution. So number 6. 6 has 1/2 x plus 1/2 y equals negative 1, and the other one is x minus y equals negative 4. So I'm going to do here, I'm going to divide everything by 1/2 on that bottom row. So that top row stays the same. 1 half x plus 1 half y equals negative 1. Bottom row gives me 1 half x minus 1 half y equals negative 2, because half of negative 4 is negative 2. When I add straight down, these cancel. 1 half plus another half gives me 1. Negative 1 minus 2 gives me negative 3. So you can see x equals negative 3. That is half of my answer. When I plug in negative 3 into this bottom one right here, I get negative 3 minus y equals negative 4. I'm going to add 3 to both sides. Gives me negative y equals negative 1. And then right there, I'm going to divide by negative 1, which gives me y equals 1. So that is the point negative 3, 1. All right, number 7. Solve using any method. Number 7. So 7 is 3x, negative 3x minus 5y equals negative 21. And the other one is 7x minus 3y equals 5. So I think I'm going to do is do linear combo here. I'm going to multiply that top row by 7 and that bottom row by 3. When I do that, my adjusted equations are negative 21x plus 35y equals, so 7 times negative 21 gives me negative 147. The bottom row gives me 21x, so those x's are going to cancel, minus 9y equals 15. So I add that straight up, goes away. 35 minus 9 gives me 26y. Negative 147 minus 15 gives me negative 132. Divide by 26, and that gives me a yucky decimal. Does it really? So let me double check that. Shouldn't give you a decimal. So 7, negative 21 minus 35y. 21 times 7 is negative 147. 21x minus 9y equals 15. So that is correct. So when I plug that in, 35 minus 9 is 26. 147 minus 15 is 132. So that does give me a fraction, unfortunately. So that fraction, negative 132/26, I'm going to reduce that on my calculator. Gives me y equals negative 66/15, I believe. And let me double check that. And that's 13. Sorry about that. Okay, unfortunately, to solve that for x, I gotta plug that in. I'll use this bottom one. So 7x minus 3 times negative 66/13, and that gives me 7x plus 198/13. So when I subtract 198 over 13, I get negative 133/13. If I divide that by 7, I get x equals negative 19/13. And I can't believe he's giving me that one. That one is pretty messy. I'm probably going to double triple check to see if I got that one right, but unfortunately I think that might be it. I'm going to use my calculator to plug those in to see, double check. So if I do negative 3 times negative 19/13 minus 5 times negative 66/13, I do not get the same answer, so I'm going to double check on that one and get back to you on number 7 there, because I'm not sure if I did that one 100% correct. But we're going to move on to number 8. Number 8. 8 has you solve the inequality, write the solution on a number line, and write the answer in interval notation. Use the union symbol in your solution when necessary. So I have 3x plus 10 less than 22, so minus 10 on both sides. Gives me 3x less than 12 divided by 3. Gives me x less than 4. If I draw that in the number line, got 0 here, I got 4 here. That is less than. So less than is always to the left. Going to be a rounded bracket and a big arrow going off to the left. In interval notation, that would be from negative infinity to 4 rounded. Number 9. Negative 8x greater than or equal to 24. If I divide by negative 8, that will switch my inequality around because I'm dividing by a negative. If I draw that on a number line, that is less than also this direction. That is a square bracket because of that inequality with a line under it. And then my line is going off to the left. To write that, interval notation would be from negative infinity to 3, square bracket. Number 10. 10 is 10x minus 5 less than or equal to 3x minus 13. So I'm going to add 5 to both sides. Gives me 10x less than or equal to 3x minus 8. Take away 3x both sides. Gives me 7x less than or equal to negative 8. Divide by 7. Gives me x less than or equal to negative 8/7, which is about negative 1 1/7. So a little bit left of negative 1 on the number line. So I draw my number line. Negative 1 1/7 is going to be about here. I'm going to draw a square bracket, and that's going to be off to the left because that's less than. So that would be negative infinity to negative 8/7 square bracket. And I'm pretty sure that is page number 1. Let's go to page number 2. So number 11. 11 is 5x less than 20 and x plus 5 greater than 4. So if you remember from last night, that's the intersection one where they intersect, and or is the union one. So if I divide by 5, that gives me x less than 4. If I subtract 5 here, I get x greater than negative 1. So if I draw that, I got 4 right here, less than, be this direction. If I do negative 1, that is square bracket, and it's going this way. So that's going to be one of those intersection ones where they're all sandwiched between them, and that would be an interval notation negative 1 to 4 rounded bracket, just like that. So less than 4, I'm sorry, that is just plain old grit, so this is going to be rounded, so let's fix that. Making sure this is a plane inequality, and then that'd be rounded right there. Alright, number 12. 12 is x plus 5 less than 6 and negative 5x. So I'm going to take away 5 there. That gives me x less than 1. Divide by negative 5 here gives me x greater than 5. So if I draw that in the number line, I got 1 less than 1. Go in this direction. And then 5 would be this direction. So I need to write two inequalities there. So I have from negative infinity to 1. And I'm going to use a union symbol here because I'm doing both those answers together. From 5 to infinity. Alright, 13. I have x less than 2, or, and that's the union symbol, x less than 8. So if I do that double one, x is less than 2. If I do the other one, x is less than 8. So all the numbers they have all the way in common, all of them would be from 8 and below. If that was an and one, I would only do that one, but since it's an or one union, that's all the possible numbers, so that would be like that. Alright, 14. 14 has absolute value x plus 1. So I need to split that up into two separate equations. So x plus 1 equals 9, and the other one is x plus 1 equals negative 9. Subtract 1 gives me x equals 8, or x equals negative 10. Because remember, I could plug in 8 in here. 8 plus 1 is 9. Absolute value 9 is 9. So that works. I could also plug in negative 10 in there, because negative 10 plus 1 gives me negative 9. And that absolute value is also 9. So that's why when you set these up, the middle part stays the same, but one is equal to 9. The other one's equal to negative 9. Alright, 15. 3x plus 5 equals 7. So split it up. 3x plus 5 equals 7. 3x plus 5 equals negative 7. Take away 5 on both sides. I get 3x equals 2. Divided by 3 equals 2/3. Over here, take away 5 gives me 3x equals negative 12. Divided by 3 gives me x equals negative 4. and those are OR ones, the union symbol. Alright, 16. That is absolute value 8x plus 4 equals 10. So for this one, I need to isolate the absolute value brackets first. So I get it looking like this. And then I split it up. So one is 8x equals 6. The other one is 8x equals negative 6. So I divide by 8. I get x equals 6/8. Divide by 8 right here. I get x equals negative 6/8. Alright, 17. Let's do 17 up here. So 17, I have x minus 7 equals absolute value 9 minus x. A double absolute value bracket. So that one I'm going to have to double check on that one. I've not quite seen a double absolute value bracket. So I'm going to pause this and take a look on Google right now. Alright, I just looked those up. So to do 17, I'll do 17 first. You set up like this. One equation is x minus 7 equal to 9 minus x, and the other one is x minus 7 equal to negative out front 9 minus x. I know that's kind of weird. So to solve this one right here, add 7 to both sides. And that gives me x equals 16 minus x. Add x right here. And I get 2x equals 16 divided by 2. So one answer is 8. This one right here, when I solve it, I get x minus 7 equals negative 9 plus x plus 7. And then what happens when I take away x here, I get 0 equals negative 2. So that equation doesn't really give you an answer. So that is my only answer right there, x equals 8. So when I do the same for number 18, I have 8x plus 7 equals x plus 6. One equation is 8x plus 7 equals x plus 6, written exactly the same. The other one is 8x plus 7. That part doesn't change, but this one, second one, gets a negative in there. So that first one, when I solve it, take away 7, gives me 8x equals x minus 1. Take away x, gives me positive 7x. Divide by 7, gives me x equals negative 1/7. The other one, when I solve this, I get 8x plus 7 equal to negative x minus 6. Take away 7. 8x equals negative x minus 13 plus x. Gives me 9x equal negative 13 divided by 9. So that other answer is negative 13/9. Kind of weird, but we'll look at those when we meet, hopefully on Tuesday. Alright, keep plowing ahead here. Solve and graph the solution set. Alright, so 19. 19, I have x minus 5 less than 4, so I'm going to split it up. One answer is x minus 5 less than 4. The other one is x minus 5 with the inequality switched and that 4 made negative. So when I add 5 to both sides, x less than 9. When I add 5 here, and when I graph it, so it's going to be from 9 less than 9 and then from 1 greater than 1. So 1 greater than going that way, x less than 9 going that way. Interval notation would be written as 1, comma 9. Alright, 20. I have absolute value x plus 9 less than or equal to 5. So when I split it, I get x plus 9 less than or equal to 5. The other one is x plus 9 greater than or equal to negative 5. So the negative one you switch. Take away 9 right here gives me x less than or equal to negative 4. Take away 9 here gives me x greater than or equal to negative 14. So when I graph this, negative 4 here, negative 14 here. Less than 4 is going solid bracket, square bracket to the left. Greater than negative 14 is another square bracket, and that's all sandwiched between. Written as interval notation would be from negative 14 to negative 4, just like that. 21. 21, I have absolute value x greater than 9. So one answer is x greater than 9. The other one is x less than negative 9. So when I graph that, I got 9 here, greater than, rounded to the right, negative 9 here, rounded to the left. When I write that in interval notation, that gives me from negative infinity to 9. Also, use that union symbol from 9 to positive infinity for that one right there. And then 22. Alright, so if you remember, for 22, it's x in equals x out. I got 3 intersections, A, B, C. So I'm going to do intersection A first. So A looks like I have 300 coming in plus 200 coming in, and that's equal to what's going out, which is x2 plus x1. Intersection B, I have coming in, I got 50 and x2. And then going out, I have 100 plus x3. I believe. For intersection C, coming in, I have x1 and x3. And then going out, I have 200 plus 250. So if I condense those down, I have 500 equals x2 plus x1. The next one, I have x2 plus 50 equals 100 plus x3. And then the last one, I have x1 plus x3 equal 450. And what I believe on that last assignment, he wanted you to rearrange these so everything is on the left. So he might have you write it like that, or he might have you switch this around so my variables are on the left. This one right here, I'm going to take away 50 and subtract x3 to get that x3 to here and that 50 over here. So that would end up being x2 minus x3 equals 50, because I subtracted x3 minus 50 right here. And that gave me the 50. And the other one is x1 plus x3 equals 450. I believe those are the equations he's going to have you use. Either those ones or these. We'll see. We can talk about that. The last part is, if he gives you x2 is 200, solve for the rest. So that means that first one, A, x1 plus 200 equals 500, because I'm plugging in 200 for x2 minus 200 gives me x1 equals 300. x2 equals 200. To find x3, I just got to plug that in right there. So I have 300 plus x3 equals 450. Take away 300 both sides. I get x3 equals 150. And that should work. 500 equals that right there. That's good. 200 plus 550 is 250. 100 plus, that's 250 right there. That works. X1 300, so that works too. So those are my answers for X1, X2, and X3. I think that's it. Alright, I'm going to pause this and go back and take a look at that next one and see how I did, then I'll finish this up. Okay, I think I found my mistake on number 7. So back to number 7, I believe I wrote the problem wrong with plus 3y. It's really minus 5y. So I'm going to multiply the top row by 7, multiply the bottom row by 3. So 7 times negative 3 is negative 21x minus 35y. And then 21 times 7, negative 21 times 7, I believe gives me negative 47. Negative 147. Bottom row is 21x minus 9y equals 15. So when I add those up, these cancel away. Negative 35 combined with 9 gives me negative 44y. 147 minus 15 gives me negative 132. And let's hope when I divide by negative 44, that gives me a nice, neat, even number. And it does. That gives me 3. So there it is. That was my mistake. I had written this problem wrong. So to find x, I'm going to use that bottom one and plug in 3 for y. That gives me 7x minus 9 equals 5 plus 9. Gives me 7x equals 14. Divided by 7 gives me the other answer, which is 2. So hopefully this will help a little bit to take a look at these. Feel free to pause it and rewind it, and then we will meet on Tuesday, I believe, I hope, and we could really focus on the ones you need to know. Good luck.